Hello, everybody. Hello, 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 and welcome to TGI Kubernetes. I am your host today, Joe Beta. For those who are not aware, TGI Kubernetes is a weekly-ish. Actually, we've been doing really well at trying to get it done almost every week. Weekly-ish YouTube live stream that we do here as part of VMware Tanzu, where me or some of my colleagues like Josh, or hopefully we'll get some more folks on board like we did last week. Show up and really help to talk about what's new in the world of Kubernetes. And then we dive deep into, some projects, some technology. Sometimes we're experts on it and we're really sort of putting it through the paces for folks. Other times we're not really as much of an expert on it, and we're, discovering it with folks, making mistakes, showing how it all works together. And this time we're a little bit in between. So we're going to be the plan for this episode is to dig into this project called SealedSecrets, which I think is really, really cool. So that's what TGI Kubernetes is. We are now on episode 132, which is absolutely crazy. I've been doing it for, I guess, years now, and here we go. And somehow, a lot of you all are still with me as we're actually playing around with this. So, first of all, hello to everybody who's joining us. I am coming from Seattle. This is my office overlooking. Usually I can see, get a nice view. But for those who haven't been paying attention, here in Seattle, we have a lot of smoke from all the wildfires on the West Coast. And so the air quality is actually pretty crappy these days. Here, let me get this. I'll show you what I'm dealing with. I now have an air quality meter that I bought on Amazon that shows me sort of what the air quality problems are. The green screen's confusing it a little bit. And this is telling me that currently in my office, the 2.5 nanometer particles are 37 micrograms per square meter or cubic meter, which is not good. And so now I know how bad the air is in my office, but I actually don't have a filter. And so there's like nothing I can do about it. So I think, around here, we're just waiting for rain so that we can actually start clearing the air a little bit. It's been pretty rough. Well, let me start off by saying hello to everybody from around the world. I really love the fact that I know this is not always the best time for folks around the world to be able to join us. But, kick back, grab a beer, hang out, and we'll explore some Kubernetes stuff together. So I want to say hello to Steve, who was here before everybody else, saying hi. Martin from the Netherlands. Sevi saying hi also. Walid, good to see you. Josh, who is a regular host now, saying hi. He's been doing quite a few of these things. Rory Boyank. Hello. Ahmet. Mona calling in from Germany. Joy from Richmond. Tim, which has a cool... Tim, how did you do the little cat emoji? Is that like one of the standard emojis? I don't know. That's pretty cool. Jim, first time from Manchester. Thanks for joining us. Juka from Helsinki. Amim Paul from New York and St. Louis. Sevi Victor from New York. Rada, good to see you. Carlos from Miami. Very cool. Haim from Israel. Tomaz, Philip from Germany. Yeah, this is just crazy. Morteza from Tehran. Good to see you. Gakhan from Turkey. Awesome. Welcome. And Massimiliano, I just want to say it. I mean, I'm sure my Italian accent is horrible. Joining us from Italy. And then Deepti from Vancouver. I'm sure your air is pretty bad up there also. Good to see y'all. Yeah, 132. Wow. So one of the things that we like to start with as we get going is we have some notes, and we have a sort of a crowdsourced document that you can all join us at. And the URL here, if you want to join us, is tgik.io/notes. Let me put that in the chat here for folks. k.io/notes. I was going to try and put it on my standard sort of breakdown on the screen here, but I started doing it and OBS defeated me in the 10 minutes I allotted before the live stream here. So anyways, you can join us here if you want to put some extra notes in there as we explore stuff. If you want to do some time code, that helps me out later as I as I go through and get this prepared so that we can get the nice indexing in YouTube after the fact. That'd be helpful. But let's go through sort of news of the week. What's been going on? And thank you. Huge shout out to George, who is always super helpful here to help curate these links, make sure that everything moves smoothly. Thank you so much, George. You're a huge help. Don't know what I'd do without you. So core Kubernetes, the 1.20 release cycle. It's been a pretty light week, but the 1.20 release cycle has actually started, and the release manager this time around is Jeremy Rickard. So, thank you so much, Jeremy, for taking one for the team. This is a big job, and I think a big part of it is executing the release processes for Kubernetes itself, helping to make sure that things converge, and then along the way, really sort of leaving the campsite better for the folks that come next, right? Really, really want to make sure that every release goes smoother and we automate things and we make it smoother one release over the other. And so, we're on, 20 plus releases now. How many releases has it been? Because, there were a bunch of releases pre 1.0 too. And it's always a big job, but hopefully it's getting better, over time. You can go to the kubernetes.dev and actually see all the information about the release, what the timeline looks like, who's leading it. This is hugely great information to understand what's happening with the release. And big shout out to George and a lot of the folks in the contributor experience SIG who put together the Kubernetes contributor website, where we have some place like this to bring all this stuff together, which is super, super cool. So all of the, all of the information around the release that's going on here. So great way to track what's going on there. Very cool. All right. So the next thing here is that we have a CVE that folks should be worried about. This is a CVE in the Linux kernel. But it's something that will impact a lot of folks that are dealing with containerized issues. And so the idea here is that memory corruption can be exploited to gain root privileges from unprivileged processes. And so the idea is that, this could be used, I think the fear is, as a container breakout. I haven't taken a close look at it, but Sysdig has a blog post here. I will accept cookies around what's going on. And so one of the things here is that it looks like the mechanism here is through capnet raw. And so this is the capability in the kernel that lets you essentially send raw packets. We've really spoofed things on the wire. This is generally not a good idea. This is generally not something that you want to give to containers. There's really only very few places where you're really going to want to use this. And so if you're using pod security policies, you should really be using those to drop the capnet raw, or other mechanisms to make sure that containers as they're launching are not actually looking for this. And so it looks like it's a incorrect offset calculation using packet sockets. And so it's relatively advanced kernel feature that most workloads won't actually need to use. So something to be aware of. If you're not using pod security policies, if you're giving capnet raw to a lot of stuff, then you're going to want to make sure that you upgrade your kernel with a patched version and work through this. Let's see, we have a 1.19.2 point release. Let's see, looks like conversions for custom metrics, panic in kube control debug when the pod has multiple init containers or ephemeral containers. And so it looks like nothing super groundbreaking here. Clearly if you're hitting that, it's bad. If you're using custom metrics, there's probably something important there. And then update the CNI plugin. So this is just a release thing. So nothing too outrageous going on there. So good to know. That's it's good. It's always good when you look at the changes and you're like, oh, no big surprises there. And then this is something that I think is really, really cool that I'm super excited about. There's now a capability in Kubernetes, and here's a blog post on it, for returning warnings. And so this is one of those things where we'll do things like deprecate some APIs or find that somebody's using something that like we're like, hey, you know what, we're going to accept this, but we really think that, you know, this is going to change or something's going to be happening over time. And then we really didn't have a way to actually return those signals to users in things like Cube, as they call things through Cube control. And so this is a great example here of like, now we can actually go ahead and do this. And if you're using, say, the wrong version of Ingress, we're going to say, hey, you know, it's deprecated and it'll become unavailable in this future version. So this is really a great way such that these deprecations and scheduled removals, which we do multiple versions in advance, right? So we're looking at 1.22, which is probably not another 6 or 9 months from now. You know, we want to make sure that we give folks fair warning as this stuff happens and it doesn't sneak up on them. And we really haven't had great mechanisms to return it. So I'm really excited to see that we now have these mechanisms for returning warnings. And so let's see. So, and then there's ways that you can actually, there's metrics for showing you that, hey, you're making a request to a deprecated API. You know, you can get the list of deprecated APIs and understand what's going on there. Super cool going on there. And then it becomes an audit annotation. And then this also applies to CRDs, which is super cool also. And so you can say, here's the deprecated warning. Like, you know, hey, this you know, example, blah, blah, blah. Very, very exciting. You know, this is really exciting stuff. And then you can do something warnings as errors, where it's like, hey, if you get a warning, you want to make sure that you know, Kube control exits out instead of actually continuing to execute that. So very, very cool. That's exciting usability thing that we're actually seeing going on there. Ooh, okay. So we had some, something got messed up in my, hey George, can you look at fixing this? Something got kind of screwed up in the notes here. Looks like things got jumbled. Any idea if OPA can take advantage of the deprecation features? I don't know. I think, let's see, where did the warnings are now a thing? Okay, so we'll go through and look at this. It says that, you know, let's see, admission webhooks are a primary way to integrate custom policies to allow a request but warn about configuration. Yeah, it looks like those warnings are actually supported now. And so, yeah, I would imagine that this is something that could work with OPA. That'd be actually a fun thing to try. I wouldn't be surprised if that were the case. So that would be really cool. Don't worry about it. I assume that in good faith, the thing got a little bit messed up here. So, okay, cool. And then there was a link in here. Yeah, so there's a link to the KEP that we'll actually get in there. And then I know Jordan Liggett, who did a lot of the work behind this, gave a demo at the Kubernetes community meeting. And so that's something that you can dig into also. Super cool. So let's check the KEP real quick. Yeah. So this is actually, I mean, like, this is a great way to look at, like, okay, what do we want to do with a KEP? Because this is the type of thing where it's a good thing, everybody can agree to it, but there's a ton of decisions to be made about how do we do this in the API, where do we do it, like how does this impact Kube control? So this is the type of thing that's going to really sort of impact different parts of it, and using the KEP process is a way to really make sure that everybody's on the same page before folks put a ton of work in here. And so, you know, I love seeing this stuff, you know, and then there's the implementation history of, like, okay, this stuff was started in April and, you know, and now it's beta and it's actually making progress. So great example of the KEP process in action. Oh, Steve's asking, what about the t-shirt today? This is a t-shirt. Oh, I love this. I'll do a little plug here because I love these folks so much. This is a t-shirt from Theory 11. Which these guys make cool playing cards, and they actually sell some t-shirts too. And I think this is where I got this one. Yeah, there's my shirt. So But they have some of the coolest playing cards, and I buy them a lot, and I'll give them away as gifts and stuff. But my favorite, and I bought a lot of these things, is they make some Star Wars playing cards. And so this is a dark side playing card, and this is the light side. And if you go and if you go to their page online, you'll see that actually all the face cards are characters from the Star Wars series. Super, super cool. Yeah, but all their playing cards are beautiful. And it's the type of thing where it's like they're a luxury, but it's like a $10 luxury. So it's something that you can like splurge on, but not feel too bad about splurging on, which is really fun. All sorts of really cool stuff there. All right, cool. All right, so now across the rest of the cloud native ecosystem, GitLab had a great blog post that yeah, so I usually carry some of these around, and so the biggest Star Wars fan I know is Tim Hawken, who leads up a lot of the SIG networking stuff, but he's been in Kubernetes forever. Huge Star Wars fan. I had these in my bag for next time I saw him, and I was going to give it to him at the next KubeCon. But then COVID hit, and all the KubeCons got canceled or went virtual, and so I'm really sad that I haven't had a chance to give him one. All right. All right, cool. So the GitLab folks actually had this great blog post talking about what's been working for them, what hasn't been working them with Kubernetes. And I really love seeing these things because, they get into the details of what is the tool set that they're using, what are some of the surprises, because they did a bunch of stuff where they were running clusters cross AZ. They saw a ton of traffic cross AZ, right? Not surprising. And that ended up being for them a cost on AWS that they didn't really appreciate. And so these are some of those practical learnings that I think is, super valuable to folks that, hey, there are pros and cons for running a cluster that crosses AZs. And this is definitely one of those things to be aware of. Things like how they're doing metrics and logging, things like reserve pod capacity and utilization. So all sorts of really practical lessons here that I think is, really, really great to actually see folks share not just their failure stories with things like Kates.af, but also some of their success stories and the lessons that they've seen. And let's see. So the Cruster, this is really cool. So George was showing me this. Let's see. I was digging into this. This is like a Raspberry Pi. So tell me more about this, George, because I didn't have a chance to look at this. What makes this different? This is like a Raspberry Pi Kubernetes cluster thing. What's the deal? What did you say? This is clusters on Raspberry Pi. There's a ton of these, but the author, which is George, has a soft spot for kubeadmin based stuff. Okay, so running a Raspberry Pi Kubernetes cluster. Okay, this is a kubeadmin based experience around this to really show you how it works. Okay, very cool. That's been on my to-do list forever, is to actually build a Raspberry Pi cluster, but I've never had the time to get around it. Like, I keep buying ARM-based microcontrollers, and I was just showing George, as we were talking about this before. Like, I've been playing a lot with, like, the latest one I bought is like synthesizers and stuff, and I've been looking at like even smaller ones. Like this is what I have here. Where did it go? Is this one called the Teensy, which is really small, and you can do a lot of audio stuff with it and stuff. So like, I want to do more of this stuff and actually start creating connections to Kubernetes clusters, and I'd love to play with Raspberry Pis. I just haven't had time to do it. So this looks like maybe this will actually get me going with it. That'd be super cool. Let's see. New version of Helm released. And this one is a security patch. So a lot of details there. Okay, Helm repo add will no longer actually overwrite stuff. So I wonder, for notable security. Okay, so they have a security advisory, and it's really great to see Helm really start taking advantage of security advisory seriously. This is really cool. Okay, so yeah, so look at this. Go before blah, blah, blah. There was a crypto package that they were using that was parsing X509 certificates that could cause a denial of service. So yeah, so good stuff like that. So super cool there. And if I'm not mistaken, there was also an announcement of like Helm 2 deprecation. Is that? Yeah, so there's a deprecation timeline, which I think folks should be aware of also. So Helm 3 was launched in 2019. Helm 2, so security patches until November. Okay. So yeah, so we're staring down Helm 2 deprecation. Something to be aware of. Y'all should be aware of that. Okay, cool. Let's go back here. And then okay, so somebody put in a link here to the CNI benchmark. Now, this is really interesting here because I know that I believe the folks running this. So benchmarks like this are always, you're like, okay, who's actually running it? And I think one of the things to be aware of here is that, you know, sometimes this stuff ends up being run by folks who have sort of a horse in the race, right? So you always want to be careful and understand. But it's really interesting to see folks start to deal with this. You know, impacts of MTU, WeaveNet. So some really interesting results going on here. So there's memory usage versus CPU usage. Our horse in the race, what we've been investing here is Antria, which looks to be really interesting. So a lot of like, looks like they're really examining this from all sorts of different directions, which is really cool. Very cool. All right, so yeah, so if you're interested in pushing Kubernetes networking speeds, you know, and performance, this looks like a great resource to at least understand sort of some of the ins and outs and the things that you really want to take advantage of. Very cool. Yeah. And I like to see that Antria is actually turning up well here. So that's really good to see. All right, cool. Let me lead the look at the chat a little bit. So lots of these Pi-based projects are custom where they use specific distros. This just, so okay. So the nice thing is that it's just like pure kubeadmin for this stuff, which is cool. Lamatti's asking long-term goal for synthesizers. I want to do stuff that's electronics that doesn't involve computers. And I know that there's computers like built into each one of the modules that I'm playing with, but it feels like you're old school doing analog stuff, which is a lot of fun. Cool. And then like, yeah. And then a pointer to the Theory 11 cards. You know, they should send me a commission. All right, awesome. So let's go and start digging into sealed secrets. And here is the web page here. So I don't think that there's anything. I don't think we have an official fancy web page beyond. And so, oh, first of all, I want to say thank you. I think he was able to join us. Marco has been doing a lot of the work to maintain Sealed Secrets here. This was originally started by a Bitnami alum who I believe last I heard was at AWS these days. This is Angus Lees. And so Marco's has been doing a lot of the work here, and just big shout out to him. What time zone are you in, Marco? This is like you're in a time zone where TGIK is not the most convenient. So thanks for really making the time to join us. I appreciate it. So the idea here with Sealed Secrets, which I think is really interesting. Oh, he's in UTC +2. So yeah, I apologize. Is, you know, you can manage all of your Kubernetes, and I love the problem here. I can manage all of my Kubernetes config in Git except secrets, because it's generally a really bad idea to check secrets into your Git repos. It's a good way to get owned. And in fact, you know, there are folks out there that actually, you know, monitor all check-ins to GitHub and look for something that looks like, hey, this is an Amazon This is like this looks like an Amazon, access key. And it's gotten so bad that now Amazon and GitHub themselves will monitor for those things and warn you. And I believe Amazon might even auto revoke the key if it sees one of these things checked in. And so, but Amazon access keys and GitHub access keys aren't the only secrets that get checked in. And so, and especially through the lens of things like GitOps and this idea of managing everything through a system of record like Git, secrets end up being a real thorn in your side. And so Steve is suggesting Git leaks as a way to protect this. So what is Git leaks? This looks cool. Scan Git repos for hard-coded secrets like passwords, API keys. Oh, very cool. It would be cool to actually scan Git repos for anything, for any secrets that are checked in, right? Because if you see a secret YAML that looks like a secret, you probably shouldn't check it in. That'd be actually pretty cool. So Paul's saying if you put your AWS key in GitHub, you'll get several emails within a few minutes, and AWS does revoke it within minutes. Or so a friend told me. It's too easy to happen, and once it's out there, you can't put that genie back in the bottle. So yeah, so Git leaks looks really useful here. So yeah, there's defense in depth, right? It's not just about encrypting stuff. You also want to make sure that humans make mistakes, accidentally check stuff in. Git leaks looks like a really cool resource there. Cool. All right. So the idea here is, how do we actually start managing secrets in the same way that we're managing the rest of our configs, whether you're using Git or GitOps, or whether you're using any other mechanism to be able to manage this stuff. You really want to have your secrets sitting next to everything else. One thing that I do want to actually, so we'll go through and install it and get going, but this is different from encryption of secrets using some of the advanced features of Kubernetes for keeping secrets encrypted. And over time, there's been sort of a continuing march to make secrets in Kubernetes more and more secret over time. And so there's still a lot of gotchas there. And Josh has done a couple of TGIK episodes where he's delved into a lot of the sort of like what's happening. I believe it was Josh did one of them at least, and touched on sealed secrets at one point. But he was really looking at sort of like, how do secrets work? What are the best practices around secrets at the cluster itself? Sealed secrets is something for managing config before it hits the cluster. And there's a little bit of stuff that happens in the cluster. So we'll go through that flow and really get into some of the details there. But at the end of the day, what it is it's a CRD plus a controller that has essentially encrypted data. And then that controller then decrypts that data and creates the secret for you. And so it's really a way of like, once it hits the cluster, that controller will decrypt it for you. So it'll actually be sitting in the cluster decrypted. But it's a way for you to actually have everything through kube control be encrypted until it actually goes ahead and gets into the cluster. So that's the general flow here. And so yeah. So let's go through and let's see here. Oh, this is new. I hadn't seen this too. Sealed secrets as templates for secrets. All right, we're going to have to dig into that. Okay. I reviewed this beforehand, but somehow I skipped over that. Okay, cool. So let's actually go through and get the thing installed, and then we'll start exploring some of those more advanced features. Okay, installation. There's like a gazillion ways to install this. And so one of the things you got to realize is that there's a helper client that we're dealing with, combined with the controller and the CRD that's actually running on the server side. And so let's go ahead and you can use customize and or a Helm chart or the operator for framework. But what we're going to do is we're just going to use the raw YAML because that's how I roll. And the cluster side we have here is on the releases page. Yeah, so that's what we're going to do. I'm way ahead of you, Josh. curl-lo. And so here we have controller.yaml. Let me know if y'all can't see this. I try to pre-flight this and make sure it's all readable. Okay, so what do we got going on here? So we have a deployment that's going to be put into kube system. Okay. And then, and this is going to have a single replica. And I'm sure that you know, I don't know. I wonder, Marco, can you run multiple replicas as a sort of a high availability thing? Do you know? And it's, looks pretty simple. We got a single container. We got some readiness probes. Some nice things here. So read-only root file system, run as non-root, run as user. So a lot of sort of lockdown stuff here. This is actually really good to see. Standard in, TTYs, and it has a temp volume mount, which is an empty dir. Okay, cool. Okay, it's noisy, so they'll fight with each other. So not really. Okay, so yeah, so maybe is there a feature request in the sealed secret repo to do sort of leader election-y types of things? That might be a fun way to actually have somebody help contributing here to this. That'd be a fun project to do. All right, so let's go ahead and and then there's the custom resource definition here. And then there's a role. So this is one of those things where, let's see. So essentially get and create for the sealed secret. Let's see, this is the role, getting access to essentially pretty much everything, unfortunately, right? So role binding here is that we're seeing that essentially, okay, this is interesting. Okay, so by default, sealed secret service proxier. So this is essentially saying anybody authenticated to the system gets access to the sealed secret service proxier role. The so I'm not super familiar with this. So this is actually saying you get access to the sealed secrets controller resource. Okay, this is to be able to draw back the public key. Okay. Maz is listening while they're driving. That's funny. Okay, so that's really interesting. Okay, so this is the proxy resource. Okay, to be able to actually ask for the public key. Okay, I want to dig into that a little bit. That's really interesting because we'll go through essentially how the public key stuff works so that you can and what happens behind the scenes with the as we encrypt a secret. We'll dig into that. There's the role binding around that. So essentially anybody can this is a fancy way of saying anybody can read the public key for encrypting new secrets. And then there's the controller itself essentially gets admin access, which is essentially the ability to list and create secrets. It's fascinating that it doesn't have the ability to read secrets, just to list. But I guess it will always list. So that actually, when you do a list, you actually get the full contents of stuff. Okay. And I think, this, and this is the unsealer. No, the unsealer does get the ability to essentially do everything you need with secrets. I mean, usually we look at things that are dealing with secrets across the cluster with a little bit of side eye, but kind of that's this thing's job. So you got to trust it. So there we go. Okay, cool. Let's go ahead and we will apply that. I have 2 clusters running because I think if we have time, I want to look at sort of like, can we create one secret and actually deploy it to multiple clusters? Because I think that might be an interesting way to do things. let's see. So the DevOps Live says, would you agree that Kubernetes secret definition should be renamed? It's just base 64, not encrypted, and relies heavily on admins to store it properly encrypted. I mean, it's secret in that it's a separate thing that can be RBACed and controlled, and we actually make it difficult to access it across namespaces. Anytime when you have automated systems, it's not uncommon for there to be things that you'll call secrets, but they get passed around as values like everything else. I think you'll look at this with config systems like, the one that I'd be, like Puppet, Salt, Chef, all those things have ideas of secrets, and they may be passed around encrypted, but like the means to decrypt them is actually fairly widely distributed also. And I think over time, we're continuing to lock secrets down more and more. The base 64 encoding, it has nothing to do with encryption. That's just a way so that you can actually store binaries in there versus, having to, manually have something know how to base 64 encode and decode. That's the only way to do it. That's the only reason why there's base 64 there. There was never a plan to have base 64 look like it was encrypted. But I don't know. I don't know if we should rename it. At this point, it's kind of moot. It kind of is what it is. Okay, so kube control apply -f controller.yaml. Okay, Steve says the key thing to remember is that the sealed secret can't be changed. Think changing namespace. You have to reseal it. Okay, so like when you encrypt it, it's encrypted for a specific namespace. You can't actually reapply it to another namespace, I think is what Steve's saying here. Okay, and so what we have here is so it went through and we applied it. Kube control get pods namespace equals kube system. Okay, everything's up and running. Sweet. All right, so now now the other thing that we have here is that we have a thing called kubectl, which is the companion command line utility that actually goes with this stuff. And so I installed that. Let's go through and we'll look at, the instructions for installing that. I'm on the Mac, so I installed that with Homebrew, but that's also available on the releases. It's a Go binary, and so it's sort of self-contained there. So you can go ahead and do that. All right, here's the main usage here. So one of the things that we do is that we can actually create a secret. So let's look at this line here, and I'll decode to you what's going on here. So Marco says, sealed secrets is very conservative, and we try to avoid you shooting yourself in the foot by misconfiguring your RBAC, etc. That's also why by default it lives in kube system. Okay. All right, so here's what we're doing. So bar is essentially the secret that we're encrypting. And then we're creating a generic one where it's essentially from file where, we're reading that from standard in. And then echoing. So you could cat a file in here or something like that, right? Or you could have this be from file here. And then we're writing that into mysecret.json. Oh, look at that. We got a deprecation warning here. So dry run. So what we're doing here is what dry run says here is don't actually create the secret in the server. Instead, just create it locally and then output it as JSON. So here we have cat mysecret.json is essentially what we have, is, the JSON version of the YAML that we would actually be uploading to the cluster. And so we're doing this just locally. And so we're essentially using kube control create as a way to sort of template and do the base 64 encoding here. You can create the secret YAML any way that you want to. You don't have to use kube control create, but this is just a convenient way to script it. Let's see. Alex says the key management to truly encipher secrets is really tricky in such a dynamic environment like Kubernetes. Okay, yeah. So there we go. And then Lamati's asking about key rotation. We'll go ahead and we'll get to that. So this is that base 64 encoded that we referred to earlier. We can do a base 64. Is it? is it dash D? Yeah, dash D, that file. Oh, let's see, we can do echo. Yeah, so there you can see bar. That's just the base 64 encoding. That's not encrypted, right? Yeah, you're way ahead of me, Marco. But then the next step of what we do here is we actually say, okay, we want to use kubectl to take the plain text secret and turn that into the sealed secret. And so we're going to go ahead and do that. Now, magic happened behind the scenes there. But if we now look at, we'll pull it up in VS Code here. If we now look at the sealed secret, what we'll see is that this is JSON also. The API, this is now a sealed secret instead of a secret, right? So we went from secret to sealed secret. And we can see that we now have a very long piece of text. So this is a way of saying bar in a very verbose encrypted way. And so, yeah. Now, what's going on behind the scenes there? All right. So what's happening here is that the controller, when it started up in the cluster, created a public-private key pair. And the way that public-private key pairs work is that essentially it's two halves of a key, and you can encrypt with the public key and decrypt with the private key. You can actually do the opposite, where you can encrypt with the private key and decrypt with the public key too, but that's not being used here. That's used for signatures typically. And so you want the public key to be public. And so what kubectl is doing is it's reaching out to the cluster, so it actually won't work without a cluster. So if I actually go through and if I do export kubectl config equals dev null, and I don't know, I haven't tried this before, and I try and do kubectl, like it'll say like, oh, no valid configuration because it doesn't actually know which cluster it's actually talking to. So let's go through and let me fix that. There we go. So now I have that cluster up and running, and so we're off to the races here. So Dennis is asking any reason to use YAML, JSON instead of YAML. I think JSON's just safer to parse generally. There's, I'm going to give a talk at some point about all the evils of YAML and sort of like some of the problems that and opportunities there. Oh, okay. And then Marco's saying that now you can actually do this with -F and -W, so it'll write to disk, so you don't have to do all the redirection tricks here, which is useful too. All right, so cool. So we have this up and running. We have this secret. And if we go through and if we do a kubectl get secrets, namespace equals kube config or kube system. One of the things that we'll see here is there's a whole bunch of service account tokens for all the various service accounts but we actually have this particular thing, and it's of type TLS because I don't know why it's TLS. I mean, you can use it for TLS also, but this is the key. And so now we can do get secrets. Oh, let me do namespace equals kube config or kube system get secrets. If we do that, okay, so there's a lot of cruft here, but what we see here is that we have a couple of files here, and this is probably the public and the private key. So this is the key, and then this is a public certificate. It doesn't have to be a certificate, but it is that actually shows what's going on here. And so this is the private public key pair that we actually have going on. And so what I believe, and correct me if I'm wrong, Marco, is that we're using some advanced mechanisms in the API server so that kubectl can actually, it doesn't actually read this resource because that'd be pulling the private key, which would be bad, and you may not have permission for it. Instead, what it does is it actually opens a TCP connection to the sealed secrets controller that then actually publishes the preferred public key to be using back out. So let's see. So discussion in the chat talking about the encryption configuration. Right. So this is about how do you secure things from Git into the cluster. There's a separate sort of thing, which is the encryption configuration of like, how do you make sure that you actually store things in an encrypted way when you're writing to etcd inside of the cluster. And so really it's like there's the, how do you get your config into the cluster? And then how do you make sure that once in the cluster is storing it and provisioning it in a more secure way? And it's really sort of, they're complementary to each other and they layer on top of each other. Okay, so that's what we got going on there. So now I'm wondering, Marco, is there a, if I look at kubectl help, is there, let's do a super verbose kubectl here. Oh, okay, we have the, oh, it'll probably go to v10 maybe. All right, so yeah, so this is what happens is that it's saying that it loaded my my kube config from here, and then it actually made this call to this particular. Now I'm running a kind cluster here, and so it's actually talking to my API server. So that's what 127.0.0.1.52888. That's my API server. And actually saying, okay, I want to talk to the HTTP sealed secrets controller, proxy that. And this is making essentially, the API server has some capabilities for some situations like this, where it'll actually proxy requests to a service that's running. And this is the way some of the things like logs and the, access to the dashboard under certain circumstances are allowed. And so this is actually making an API server, an HTTP call to your API server. And then the API server is then proxying that through to the actual service that's running on the cluster. And it's asking for the certificate that it should be using to encrypt things. It's getting back the certificate PEM, and it gives you 200 OK, and it's actually returning the contents there. And so this is how the kubectl is actually getting that, using that public key to encrypt things, and then writing that as a sealed secret into that file. Okay, so there we go. So now what I can do is we're going to go through the next step here, and I can actually go through and do a kube control apply-f sealed. What do we have? My sealed secret .json. So this goes ahead and creates this in the cluster. And now we can do a kube control get secret, get sealed secrets. We can see it's there. But one of the things that we can do now is if we get secrets, we can actually see, oh, look, here's that secret. So what happens is the controller watches for any sealed secrets and then decrypts those things and writes out regular old secrets. So now I can go through and I can get secrets, my secret, oh, YAML. There we go. We have, there's the data, the base64 encoded foo. Okay, so here's the deal. Anybody can go ahead and that has access to the Git repo can read that sealed secret. Only people with permission to create a sealed secret in the right namespace can upload that. And then only with people that have access to read secrets from that namespace or start pods that have access to that secret are allowed to actually then go ahead and read the plain text of the secret. So if I were a different user that weren't admin on this cluster, I wouldn't be able to read this secret. And I wouldn't necessarily be able to, I could maybe upload it to the wrong namespace. And I believe if I did that, then the controller for sealed secrets would refuse to decrypt it. And so this was a secure way to get the secret into the cluster, but once it's in the cluster, it's really just like any other secret that you've uploaded to the cluster. It doesn't actually save you or improve security once things are in the cluster. It's really about getting it into the cluster is what Sealed Secrets does. So Marco's saying that using the proxy is currently a pain point because some cluster configs like Kubernetes with private control planes. Yeah, so there's a lot of smoke and mirrors for the way that proxy mechanism works. Generally in Kubernetes, all things call into the API server for things like logs, for things like these HTTP things. It's actually one of the few cases where the API server calls out to the kubelet. It's kind of an exception there, but it's used for streaming logs. It's used for things like this. So it's a little bit of a corner case that I think if we had to do Kubernetes over again, I'm not sure how do we do this, but I think we'd probably break the proxy out into a separate type of controller, separate from the API server. So Steve says, the controller is globally scoped in terms of access to sealed secrets by default from memory. Yeah, I think the controller will look at everything, but I believe, and Marco, correct me if I'm wrong, and I think this is one of the advanced features that we can get to, is that when you actually seal a secret, you can seal it for a specific namespace, or you can actually seal it across the cluster. And I think that's something that's worth getting into. So there we go. So that's the main flow that we're talking about here. And so that's actually pretty great because now I can create a secret, check it into Git, and I can kube control apply it like everything else, and it'll just magically work. So that's actually really, really cool. So some of the sort of the next things that we want to actually start talking about here. So I want to understand this template thing, but like things that I want to investigate with the rest of TGIK. What does certificate rotation, your secret rotation looks like? What are the different types of rotation and how do those work? How would we actually make this work across multiple clusters? Can I actually have one secret that I can actually deploy to multiple clusters? What does that look like? And then the third thing that I think is worth looking into is I want to understand the scopes and the template stuff that's here because I think that's really interesting and I had missed that before. So let me go ahead and read through that real quick. The previous example only focused on encrypted secret items themselves, but the relationship between sealed secret custom secret is similar in many ways to the deployment in pod. In particular, the annotation labels of a sealed secret resource are not the same as the annotations of the secrets. Okay, I get it. So this is like, what are the things that we want to actually put on the metadata? What is sort of the metadata template of the secret that we're going ahead and creating? So this is a way of actually specifying labels and annotations and things like owner references of the secrets that end up being created. Okay, that's super useful there. I get how that works. And then, okay, so here's one thing that's actually interesting here, is that we can go through and right now, kubectl by default will actually talk to your cluster and pull that certificate back out. But we can actually go through and we can grab this thing explicitly. And so let's see, what's the best way to extract that, Marco? Do you know? Kube control, or... So we can go through and there's a whole bunch of things here. You can get it via kubectl. So how do I actually how do I dump the public certificate? Okay, kubectl fetch cert. So we can do kubectl fetch cert my cert.crt. Okay, so now we have the certificate. So you know how I did before where I set, export kubeconfig to dev null, and now kubectl this thing's going to fail because it's like, hey, I couldn't load the file. Well, one of the things that we can do here is looking at this is that I can actually specify the cert here. I called it mycert.crt. Oh, and it says no namespace and cannot infer it automatically. Okay, so now let's go through and we'll change our sealed secret. We'll change this so that we'll go namespace default. Boom. So now what we did is we sealed the secret without actually having access to the cluster. And so that's an important thing, is that you may actually have situations where you want to seal I could pass -n default to the kubectl also. But you may have situations where you want to seal the secret where you don't have immediate access to the cluster. So that's a useful thing to know there. So that's cool. Okay, so the next thing is which is interesting here is let's go through and let's experiment again. We'll do cube control create namespace test. Okay, so we've created let me fix my cube config. So now we've created a test namespace. And now what I want to do is I want to do cube control. So now I'm going to look at my sealed secret and I'm going to be like, I'm a hacker. I want to go through and I want to change the namespace here to test instead of default. And I'm like, well, I got access to this. I have access to the test namespace on this cluster, but I don't have access to the default namespace. Now I can do a cube control -n test apply -f my sealed secret.json. That went ahead and created it. And now if I do a get secrets, you can see that the sealed secret controller did not decrypt it this time because I took something that was meant for the default namespace and I applied that to the test namespace. And so this is a security precaution to make sure that, hey, if somebody seals a secret for one namespace, they can't use it in another namespace. But that's, I believe, where the scope feature comes in. So now we can go through and we can say strict, and it must be sealed with exactly the same name and namespace, but we can actually change this so that it can actually be cluster wide. And so now let's go through and actually let's seal the secret again. Oh, it's also because you manipulated the sealed secret contents. Okay, does it actually seal the entire, including the metadata? So maybe Marco says no. So the metadata is not actually encrypt. Okay. But yeah, so regardless, I tried to use a cross namespace and it's like, hey, I don't like you doing that. But now we can call kubectl, and what we're going to do here is we're going to do scope is cluster wide. So now we're going to go ahead and do the same thing. And then let's look at the sealed secret here. You'll notice that now there's an annotation here saying that this thing is cluster wide. Okay. And now I'm going to change this thing to test. And let's see if this works. So now it got deployed. Now if I do a get, now you can look and see that, oh, it went ahead and it actually decrypted it for me. And so, yeah, so you get the choice of whether you want to actually seal the secret just for a very specific name and namespace, whether you want to do it across the namespace where you can rename it. Like maybe you're actually versioning your secrets in some way that like you want to have the sealed secret, but then change the name as you actually apply it. Or whether you want this to actually work across the entire cluster where anybody that has access to that cluster can go ahead and actually decode that secret. Oh, it's raining outside. That's really good news for the air quality. I'm very excited. So that's a really cool feature there. And I think that shows you that, like, I'm sure over time, the whole subtleties around namespace, name specific versus cluster wide, a lot of folks have sort of hit their heads against that, I'm sure. Okay, yeah, Mark, this is really interesting. The annotation gets put in the template so that it actually gets copied into the decrypted secret so that you can actually round trip this. So if you actually go ahead and pull it, you can actually change it and then re-encrypt it without actually losing some of that metadata. Yeah, so that's actually really cool. So that's a sort of reality of this, that round tripping and making sure that these parameters are round tripped with it, that I hadn't really understood before. So that's really cool to see how that works. All right, so that is the way that this stuff works. Very, very cool. Now, the next thing I want to do is secret rotation. And there's two types of rotation that we should really talk about here. Okay, and Marco says the main problem is that the error messages are currently crap. Like, there is no way to get feedback that, hey, you know, I didn't decrypt this because it was only to, you know, you were using it on the wrong namespace, something like that. Yeah, the way I would do that is I would have like a condition in the status of the sealed secret. That would be probably the right way to deal with that. All right, so key rotation. So there's two secrets that we're talking about here. There's the secret for the sealed secret controller. That's that certificate and private key that are created when you first install this thing into the cluster. So that's the first secret that we want to worry about rotating. The second thing that we want to worry about rotating is the secrets yourself, right? So like, you know, any secrets that you're putting in there, you probably want to go ahead and rotate those things. Sealed secret cannot rotate your secrets. What sealed secrets can do is actually rotate the key that it uses. And by default, that happens every 30 days. And what happens is that when it actually happens every 30 days, the sealed secret controller will go ahead and create a new secret, a new key value, public key, private key pair. It'll keep the old private keys, but it'll only then serve up the latest version, and correct me if I'm wrong, Marco, it'll only serve up the latest public key. And so that means that at that point, when the controller does a key rotation, all secrets encoded after that point will go ahead and be encoded with the new key. But all secrets that you were sealed beforehand that are now checked into Git that may be 6 months old, those things will actually still continue to use the old key, and the controller will know how to actually decode those things. And so that's something that to be aware of, is that it'll actually, but for you to really sort of take advantage of that sort of that new key that the controller is using, you have to go back and reseal the secrets that you've had so far. And so we're going to actually go ahead and do that. So like what I'm going to do is there's a way to force early key renewal on the so Maddie's asking, how does it maintain mappings? My guess is that there may be a key ID that's encoded in the sealed secret, or it just tries them all and sees which one works. Right? I think at some point, like, you know, there's that might be something that works also. I'd be interested to know whether there's actually a key ID that ends up getting used as part of this. Okay, so we can do date-r. That's the current date. Hopefully it's time zone aware. And now what I'm going to go through is I'm going to change the controller YAML. And we're going to go to the deployment here. Command, controller, args. Oh, where's args? Okay, it tries them all, and the key ID is planned, but it has to do it in a backward compatible way. Okay, so now what we can do is we have this flag to the controller called key cutoff time, and I'm going to set that to this thing here. Okay, so now what we're saying is that this will force a new key, the controller to actually create a new key when I actually push this. So cube control apply controller. We went ahead and did that. Cube controlled cube system get pods, and we can see that sealed secrets controller, the new one is running, the old one is being brought down. At some point. Okay, and then if we look at get secrets, now what we see is, and I don't know, but like the certificate here, I think is probably a new certificate. But this key is probably includes both keys, I believe, or maybe, let me see here, secrets. Yeah, so it now has a secret, but my guess is that the private key is actually now contains multiple private keys. All the old private keys too. And so, I mean, we can go through and let's do this. I'll grab this. We'll do pb paste base 64-D. And so this is RSA private key. Is this a single private key? Where are the old private keys? Oh, they're okay. Marco's saying there should be multiple. Okay. And I'm not. Oh no, I'm not seeing the multiple private keys here. What did I do wrong? So it's been running for 2 minutes. Cube control logs. And cube system logs. Okay, so Marco said he missed the part where I triggered the renew. Maybe I did it wrong, so tell me if I did it wrong here. I said key cutoff time, and then I specified especially now in using the date-r. Is that time zone aware? I would expect that this would actually create a new one. So like what I was doing is the early key renewal. A key can be generated early by passing the current timestamp to the controller into a flag called key cutoff time. So should be, seems correct. Okay. But yet, here we are. Let me go through and let's do. Oh, you know what? I'm a dumbass. Okay. Let's see. I should have passed. Yeah, let's do that. Okay. Okay, now. Okay, so now we have multiple secrets. Okay, and how do we know which one is the latest? It probably loads them all up. Not -0, -O. And oh, it's timestamp based. Is it based on sort of the creation timestamp then? Or is it based on a timestamp that's embedded in the certificate? Okay, so it's the creation timestamp that it's actually using. Okay. So the last secret that is created is the one that the sealed secret will use. But now what we'll find here is that I have a secret that's existing already, this my sealed secret. And that was encrypted with this certificate here, right? But now we can go through and I can seal it again. And so what you want to do is you want to do cube seal, and we'll do we'll take off the, let's see, we'll do my sealed secret 2. And now if we do diff my sealed secret, we can find that these things are now different because, oh, well, one of them was cluster wide and one of them wasn't. But like, but it's actually now using that new certificate that it actually grabbed down from the cluster. And so we can go through and, yeah, they would have been different. Oh, does it actually put a timestamp in there? So they would have been different anyways. Okay. My cert. So we'll do my cert 2 here. And so, you know, we can see that my cert. We can see that the certificates are now different because we're using one certificate versus the other certificate. So that's the way that you rotate it. But again, sort of like we can still have, you can have a whole bunch of secrets that are now encoded with the old secret. And so that's something that you actually want to be able to be aware of. And so a couple of things that you want to do for good hygiene as you use these systems over time. Every once in a while, you want to actually go through and there's some explanation about sort of like the two different types of sort of secrets that we're dealing here. So you want to actually go through and actually call this sort of re-encrypt here and make sure that we do this. And does the re-encrypt actually work in place? Is there a way to do that? But you can go through and Steve's saying that they automated it in metal. Encrypted the same clear that creates two different types. It uses a nonce. Oh, there's a nonce in it. Okay, cool. And so there's a re-encrypt, which is essentially says, use the re-encrypt the given sealed secret to use the latest cluster. So how does that work? I wonder. So Maddie's asking about the private keys for the life of the cluster. So yeah, so the first thing you want to do is you want to automate, you want to actually re-encrypt this stuff here. So let's go ahead and do this. So we're going to go through and we're going to do re-encrypt my sealed, well, that's wrong. Okay, so we're going to do re-encrypt my sealed secret.json into temp.json. Oh, actually, I want to give this a -v10. Ah, so this is really cool. Oh, look at that. It's Duffy. Hey, how's it going, Duffy? So this is really cool. So what it does is that when you do this rotation, you want to do the rotation on a sealed secret, but you don't want to necessarily ever see the private key, and you may actually only have the crypto text. And so the way the rotation does is it actually uses that same mechanism to talk to the controller and calls a different endpoint on that controller saying rotate it. And so when you rotate it, you send it one sealed secret and it sends you back a new re-encrypted version of that. And so this actually uses this so that you actually never see the private key. And so this is great because you can do a whole bunch of workflow here with never actually seeing the private key. So that's pretty cool. Yeah, so write only. That's super cool. Okay, so you then so good hygiene is like once in a while, once a month, once every couple of months, you want to go through and do this re-encrypt, or better yet, you want to rotate your secrets, right? Because you shouldn't be using any passwords over the long term anyways. But, you know, oftentimes those secrets are manual and you don't want, you know, and rotating them is a pain. So you should at least make sure that you're using the latest certificate from Sealed Secrets. And then the question that that Lamatti had, which is like, hey, does it keep these things around forever? And the answer is yes, it does. And so like when we went through and we actually looked at, see, get secrets. When we look at it, and now we have two of these secrets here. Every 30 days, it'll create a new secret and it'll actually leave the old secret behind. Currently in Sealed Secrets, there is no mechanism to automatically prune the old secrets. And so if you do want to prune and you have that re-encryption process in play, then this is the way that, like, hey, you know what? I want to keep 6 months worth of old keys in case something's left around for a while, and then I want to go ahead and re-encrypt. It would be useful, I think, to be able to do an audit to actually say, are there any sealed secrets in my cluster that are encrypted with a secret that's more than, like, say, 6 months old? So I think I could see some mechanisms for being able to say, hey, does my cluster have a clean bill of health? Is it safe for me to actually delete and garbage collect this stuff? That would actually be something that would be useful here. So yeah, and Marco says it can be useful to upgrade your sealed secrets to a new file format without knowing your secrets. And so yeah, interesting stuff. So that's how rotation works here. Let's see, and so that is, so the only thing that I want to play with yet that I'm not quite sure how to do, which is how do we actually deal with multiple clusters? Can I actually deploy the same sealed secret into multiple clusters? So let's go ahead and see if we can do that. What I think I need to do is to install sealed secrets into a new cluster, and then go through and take the sealing key, the one that I care about, out of cluster A and install that into cluster B, and then automatically things will start working. And so I just need to go ahead and install the new one in there. Labeling a sealing key secret with anything other than active effectively deletes the keys from the sealed secret controller, but is still available in Kubernetes for manual encryption. Oh, this is weird. Okay. Sealing key with anything other than active. All right, well, let's get into that. We'll go ahead and look at that. Okay, so what we have here is, we have, this is the new secret that I just created, okay? And so, and let's make sure that kubeseal, and then I move temp.json to my sealed secret.json. So now this is actually signed with the new key. And, oh, this one's cluster wide, whatevs. Okay. And then we can go through and we'll do apply. Okay. And then we can do kube control get secrets. All right. So we got this up and running. It's been there for a while. Nothing has changed. And then Marco says, okay, you need to manually kick the sealed secret pod when you copy around private keys. Okay, yeah, that's going to be another issue if you do an HA sort of multi, because you may have, like when it's time to rotate, you only want the leader in the leader election to do the rotation, and then you want all the followers to actually be able to pick up the new key. So that'd be another piece of the puzzle if you're going to do an HA version of sealed secrets. Okay, so now what we can do here is we're going to go through and we're going to do get secrets out of this namespace. We're going to grab the newer one here, that dash o JSON, and then we're going to write that to, what do we call this? Yeah, PR's welcome. I should get on that. Sealing key.json, okay? So now we have the sealing key.json. This is literally the keys to the kingdom right here. So you do not want to check this one in. Do not check it in. So Steve says, HA sealed secrets is painful unless you actually do that. Yeah. Okay, so now I have another cluster here. So this is a kind cluster that we haven't done anything with already. I'm going to do a kube control apply -f. I'm going to actually deploy the controller here. And this thing is up and running. Kube control, kube system, get pods. And you can see that it's been running for 12 seconds. Again, this is cluster 2. I don't know if you can see up in the corner here, we have kind 2 versus kind 1. So this is up and running. Now this thing because it just started, it has gone through and actually created its own key off the gate, off the bat. So now if I go through and if I try and do a kube control apply -f seal, no, it's the my SealedSecret.json. Oh, what did I screw up here? Oh, test. Oh, we'll do default. It's cluster wide, so it should be fine. Okay. All right, so that created, it's fine. Yeah, hey, no problems. Kube control get secrets, but it hasn't decrypted it because literally this cluster can't decrypt it. It does not have the private key to decrypt that particular secret. So let's give it that private key so that it can go ahead and actually decrypt that secret. So if we go through, we have our sealing key here. And here you can see this is the label name active that says, hey, this is a key that should be active. We can go through and we can do kube control apply -f sealing key. Why does it have, yeah, okay, sealing key. So we can go ahead and do this and apply this into the new cluster. And so now when we go through and if we do get secrets in kube system, now you can see that we have both of these things. Okay, now what Marco said is that this isn't quite good enough. One of the other things that we need to do is we need to actually go through and actually kick the controller to actually have it go through and update. And the way I'm going to do that is we don't need it anymore. So I'm going to go through and I'm going to delete that cutoff time thing that I added earlier. So now when I apply the controller, what did I do wrong? Do I need a... Oh, this is an array. So now we've gone through and we've actually deployment configured. Okay, so this will roll it. And now we have the new one up and running. And let's see. Boom, it did it. So now this controller had access to that new key. I kicked it, I added. So now I actually have the same sealed secret actually being deployed to multiple clusters. So I think that there's, another place where I think it would be cool to have is to have some workflow really well documented for how you actually manage sealing secrets across multiple clusters. And there, and there's another interesting feature here would be like being able to actually say, well, this particular sealing secret can only be used with these namespaces. I don't know. I'm wondering what the scenario would be there, but I can imagine that there might be some scenarios that would actually work for that. So that is really cool because I think that's one of the things that's like, hey, this works great in one cluster. How do you actually start dealing with it with multiple clusters? And sort of one answer there could be that you actually have multiple sealed secrets based on which cluster you're targeting. But the other answer would be to start using the same sealing key across multiple clusters. And probably as you did this, you'd also want to start managing the certificate that you're using to sign it also in a more explicit way. So you'd probably want to turn off the rotation that happens automatically and actually manage that in a more sort of explicit way across cluster in terms of when you update, when you change, how you install your sealing keys. Steve says that we have that set up for PI-specific namespaces that only certain people can create secrets for. Okay, very cool. Yeah, and so I think, one of the things that I think would be interesting in KubeSeal, I wonder if it supports this, is can you create a sealing secret from KubeSeal without actually running the controller? So that way, if you're managing this stuff, you don't have to sort of like, futz with the controller to create a secret so that you can actually go through and then have this stuff use it. And I don't know. There's the recovery unsealed, decrypt a sealed secrets file obtained from standard in using the private key passed in with recovery private key. Okay. Re-encrypt. So you can unseal a secret manually with recovery. But I'm wondering, like, is there? So what I have here is I have the sealing key, right? This thing here. That what I did is I manipulated a controller to automatically create one of these things, and then I grabbed it. I'm wondering, like, if I wanted to have a multi-cluster flow where I wanted to say, hey, controller, never create a sealing key. That's going to be managed from the outside. Can I run the controller in a no key management at all, and then use kubectl to create a sealing key out of band and actually manage that as sort of like an admin task? I think that might be for the multi-cluster flow. You know, there's this idea like you'd have one primary cluster and a bunch of secondary clusters, but could you actually say, oh, I don't have a primary cluster. I actually want to have my command line tools, a manual process for actually managing and creating that. That might be something that would be interesting for that flow. But very cool. So hopefully, I think, I'm running down the clock here, and I think we've covered a lot of the highlights of what we want to do here. So a couple of takeaways here is, first of all, sealed secrets is not a replacement for encrypted secrets in a cluster. It's that's one thing to actually be aware of. It's really about sealed secrets is how do you manage secrets through things like GitOps, separately from how do you manage the secrets in the cluster, right? It's about getting things into the cluster. Second thing is that rotating the sealing key in that cluster is a little bit of an advanced procedure. It'll happen automatically for you, but if you want to make sure that you can rotate that, you have to go back and essentially reseal or re-encrypt all of your secrets. Now, you should be rotating all your secrets regularly anyways, and they would get the benefit of resealing, but it's something to be aware of, is that, there's your secrets and then there's the sealing secret, and those things have to be rotated separately. Something to really be aware of. And then the third thing is that it is possible to manage these things across multiple clusters, but you have to start managing those sealing secrets and making sure that you can use those across the clusters. That becomes a manual thing that you have to start dealing with. And then Lamati says, Joe, what are your thoughts on placing sealed secrets in Git and allowing Flux Argo CD to pull those into a cluster? Yeah, that's exactly the type of thing that you want to do, is that you want to be able to put these things in Git, deploy them like you deploy everything else, but know that they're not going to accidentally be published to GitHub in a way that anybody and their brother can decrypt them. Another thing to be aware of is, there are limits to cryptography, and what looks solid now from a cryptographic point of view may not be solid forever. And so theoretically, from a sort of PKI point of view, taking that ciphertext, taking that sealed secret and publishing it to the world, checking it in GitHub, posting it on Twitter, that should be okay. But depending on the environment that you're in, whether it's a high security environment, there may be regulations that say you want to be careful about even controlling your ciphertext. And so there's sort of like what is reasonable and what is sort of the compliance and the regulations and the different requirements that you have to hew to. So sealed secrets is secure as far as we know, as far as the public key cryptography is secure. It's still worthwhile to think about protecting the ciphertext. And, and there are going to be environments where sealed secrets may not be good enough. And that's just something that you have to know your environment, you have to know what's up to snuff, and you have to be careful about that. Yeah. So Marco says, with respect to multiple clusters, one big feature we're working on is to support KMS service provided by major cloud providers. Oh, that's awesome. So now the sealing secret is not actually stored in the cluster. It's something that's managed by some external service. That's actually really cool. Mo's asking, was storing secrets in Vault covered for application level secrets? No, this is actually something that would be separate from Vault. I think that there is, I would be interested in exploring sort of the interplay between how things work with Vault, where you're actually having the secrets stored someplace else and you're sort of bringing them into your workload as late as possible, versus sealed secrets. And are there ways that we can actually sort of interplay the management around these things? So very cool. And Steve says, this is what Eric does with Flux and SOPs. He links his blog post in the HackMD. Oh, so let's go ahead and look at that. Managing, what is SOPs? Mozilla SOPs has support for multiple sources of key material. So how does this work? All right, so this looks like an interesting thing to look at. So you're using something like create key with a KMS. You're using Flux. Where and how do they get actually decrypted? Is there a controller that does this? Or you leave it to the workload to actually go through and actually decrypt it? Is that the idea? So yeah, I'm guessing that you leave it to the workload to do the encrypting. So there's no sort of automatic going on there. So cool. So Flux does Flux actually know how to actually deal with SOPs directly? That'd be interesting. Okay, cool. Well, that's it, folks. I'm going to sign off. Let me switch this things here. Okay, and so Moz says that SOPs has nice integration with customized decrypt secrets. But then you would decrypt them on the way to the cluster. Okay, I get it. So you'd be doing that decryption client side versus server side, but you would need access to the KMS provider to be able to do that. Cool. So, all right, folks. So thank you for joining me. This was a little bit of a deep dive into Sealed Secrets, something that I've been meaning to do for a while because I've never had a chance to actually dig into this level of detail. So really cool to see that happening. And hopefully this is useful for folks. And I think, understanding the different pros and cons, pluses and minuses, the different layers of security here. It's complicated stuff, but hopefully, we have the right tooling. The documentation here looks great. So hopefully this is something that's useful and y'all can start applying it in a smart way. And so thank you for joining. And I'm not sure who's going to be on next week. Maybe Josh, maybe we'll have some of the newer folks like Paul and who did it last week? I wasn't able to tune in. It was Paul and I haven't met her. Was that Carla who was helping out? I'm trying to remember. This is the Cora, Paul and Cora. I heard they did a great job. So maybe it'll be Paul and Cora next week. I think we tend to play it by ear and see who's going to be doing this week to week. But tune in next week. I'm sure we're going to have something exciting from one of us. And thank you all for joining us and have a great weekend.